see the details of the structure of these cells in details now in this class. BSR forms the boundary scan chain. Right? So all the input outputs are part of the boundary scan cell. It's extremely important to understand what is a boundary scan cell and how it behaves. Okay, let's go ahead. Boundary scan cell. So in the previous diagram, we saw what is a boundary scan cell. And now in this slide, we are going to see what is an input boundary scan cell. So each boundary scan cell on the input side has two flip-flops, as you can see here. One is a capture or a scan flip-flop. One is an output flip-flop. So let's see what is a capture slash scan. If we have not gone to the details of the DFT yet, we are trying to look at the high level side. So let's use the English to understand what do you mean the capture? What do you mean the scan? Pause the video for a minute. Okay. What do you mean the capture? The police captures a thief. Okay. That means you have to capture something. You have to capture a data. You want to latch onto the data. Flip-flop registers the data. So it captures the data. The input. What is a scan? The scanning, CT scan. What do you mean? Please think about it. And there's the output flip-flop. Right? So there are two flip-flops. So it's important to remember these architectures. Please don't by heart. Please understand. It's very basics to understand the system level concepts. Without by hearting, understand the concepts. We'll see application of the concepts later on. There are two control signals called shift DR and mode. Right? Shift DR is here, mode is here. There are two control signals. So I would assume that you have thoroughly mastered the JTAG standard, the tap controller before you go into this. If you are not aware about the JTAG tap controller, go back to the previous video and understand. Okay. And there are two clocks, clock DR and update DR. So clock inputs to two flip-flops. One input flip-flop and output flip-flop. Or one is a capture, one is output flip-flop. Okay. So this supports four operations. What are they? We shall see in the next slide. So mode number one. So there are four modes. First mode is normal mode. So system pin to system logic. This is system pin. System pin comes from the IO pin of the chip. Okay, and system logic is your input output cell, as you see here, right? This pink color cell is expanded to this diagram. So you can see how this input cell, you are giving the input at this pin, and this color is output of this particular IO cell. This is part of the IO cell, remember, this is internal to this IO cell. Okay, so BS is a transparent. Again, pause the video and understand what is transparent. Okay, what do you mean by transparent? It's general English, just a feed through kind of thing. What are you giving the input? It goes to output. So mode is an important control signal for that. So in the normal mode, there are four modes which I'll see: scan, update, and capture in the coming slides. Let's talk about the normal mode. The mode is 0. The shift DR pin is a don't care. This is where the shift DR. This pin is a don't care. It's X. That means it can have a 0 or 1 or any value. The mode pin is 0. That means the clock takes the system clock. Then system logic. The input is going to output. It's going to take something called a system clock. This is not mentioned here in this diagram. So it's operating at the system clock frequency. Okay. So this is very transparent. In this mode, and mode value need to be 0. Let's see the scan mode. And you have to understand what is the application of these modes. Now you have to correlate this with what you read in the JTAG tap controller. Now you have to apply the concepts. Right? That's your job. So apply, you have to learn. I'm making you think. Any questions you can deliberate. Shift from one scan flip-flop to next scan flip-flop. Right? So there are a bunch of scan flip-flops are there. There are 8 IOs in our example. There are 8 flip-flops. So how do we scan the data from? We shift the data to the output. We saw in the examples before. We shift the data from the front pin to the last pin. How do we shift it? So you have to understand the application. Look at the concept now, right? Scan does not interface with the system logic. What do you mean the system? Already told in the first lecture about the making of a chip, right? So go back and understand what is system. So scan does not interface with system logic. Scan happens independently where the system is working on its own. So let's see. So for this mode, shift DR should be 1 and mode is don't care. The scan mode, shift DR is 1, mode is don't care. So why it has to be 1? The data from the input pin, this mux has to be selected, right? So this path has to go from the last cell. As you see that from the last cell, it has to go to the next cell. So it has to be this mux, this particular path has to be selected. It goes to this flip-flop and it has to go to the next cell. So mode is X, you don't care about the mode, whatever it is. Your output has to go to the next cell. Look at this bigger picture, this diagram. You're looking at inside this particular cell. This gray area is inside this particular cell. So this is the data path that you chose. You know what is the data path? Look at your Verilog class. So this is a path we have to choose, right? So for this to happen, what should be the clock? You have to give a clock DR 1 pulse. You have to give it. Right? So what is the clock DR? Go to JTAG tap controller and understand. Then that's third operation of the input boundaries cancel. It's called update operation. What does the update do? You have a data in the scan flip-flop. You want the data to go to the system logic. So we have to load the data from the scan flip-flop to the output flip-flop. Remember, we spoke about two flip-flops, a scan flip-flop and an output flip-flop. So how do we transfer the data from one flip-flop so that the logic goes to the system logic? In this case, mode need to be 1. So what is the use case? What is the application? Applying the test pattern to system logic. You are applying a test pattern, which is through a ATE tester. That need to go to your internal logic, system logic. So you have to use this particular mode. So that's application. Now you understand the concept. Concept is this particular table. Application is this particular line. Okay, so don't forget. Rewind the video and review again if needed. So in this case, the mode need to be 1 and shift DR is don't care. So mode pin is 1, so it take this particular path. And you have to give update CR. You have to give update DR state. The clock is update DR. Right? You update DR clock. Then the data gets registered on the input, on the memory input. Shift DR is don't care. So it can be from anywhere. And the data goes to system logic. Okay, hope it is clear. Please do ask questions if needed. There is operation 4. You have to capture the test responses. So what is the ATE we have to do? We read in the previous class or the before class, the introduction, last part of the introduction class. You have to capture the response and compare against the expected response, right? So how do we capture the test response? From the system input into the capture flip-flop. So it's the capture flip-flop, the input need to capture it. So for this shift DR need to be 0. Right? How do we capture the input data? So the shift DR need to be 0 and this pin, mode pin is don't care. So data comes to this particular path, goes here, gets captured from the system pin, right? Gets captured, the capture flip-flop. So that's what it does. Very simple operation. Please remember all the 4 operations, extremely important. You have to apply the concept, then you'll understand what is boundary scan. It all looks simple, but as I said, you have to connect all the dots. You have to you have to visualize. Extremely important. So the 4 modes we have reviewed so far to review: the normal mode, scan mode, update mode, and capture mode. Okay, let's move forward. So summarize. Normal mode. What happened? You pause the video and write your notes and then discuss the class with your peers. Pause the video. Okay. So now we are going to look at the output boundaries cancel. This is part of the output of the chip. It's exactly same as the input boundaries cancel. but only different is the direction. Just do a mirror image of the previous logic what we saw. We had a system pin here, the system logic was here, right? So exactly reverse. I cannot go back to the previous slides unfortunately, since I'm recording a video. So you go back to the previous slides and you check it, right? So that's only one difference. Let's see the next slide. Okay, this is a example for you. This is a follow-up work. Short assignment for your own interest. Please fill the table for the four operations. Pause the video, no cheating. Fill the table based on what you learned in the input boundaries cancel. You recollect and write this. I fill up this table. Pause the video. Once you fill up the table, you can go ahead. Okay. You did get the right answer. Please deliberate. Any questions? Please talk to your own friends and understand. Or you could ask me a question. Okay, next interesting topic. We're going to talk about the instruction register or IR. What is the purpose? We have to ask the WH questions, right? The entire course has been structured as much as possible that way. So what is instruction register? You all know the understand because you know what is a microcontroller or a microprocessor, right? So what is the purpose of instruction register? To shift in the instructions from the TDI. So for this again prerequisite to understand the JTAG tap controller, it's a self-study. So shift in instruction from the TDI. Okay, you shift in the instructions. Then store the instructions. From the TDI, you get the instructions. Goes to the all the boundaries cancels. Goes to tab controller. And also goes to instruction register. We saw in the introduction class, the previous class. You have to store the JTAG instruction in the instruction register. The input instruction come from this. Store it here. Then what will you do? Once you store the thing, you have to decode. We'll see that in the subsequent slide. So for the instruction decoder, you have to save the instruction. You have to load the instruction system. Compare with your microprocessor or a microcontroller. It would be clear. Okay, what does the instruction register contain? It's very simple. I pause this here. You read it on your own. It's very easy if you understand what is digital electronics. This is self-explanatory. Pause the video. Okay, have you understood? This basically explains there are two layers. One is a scan flip-flop layer. One is an output flip-flop layer. Right. So this is output flip-flop. This is a scan flip-flop layer. There are two layers. So it's a four flip-flops each. How to load the instructions? Follow this. Keep the JTAG tab controller diagram in front of you. This is how you load the instructions. Then you update IR state. So loading the instruction register does not interface with instruction decoder work. What is happening? You load the instructions in parallel by applying the clock IR. When the update IR comes, only it goes to the instruction decoder. Right? Very simple. Shift register with SI and SE. SI is the serial input. SE is the enable pin, the clock pin. DI is the data input. Right? This is a scan mux flop. We are not seeing those in detail. Based on the shift IR, when either the value of the DI takes, there's a mux, assume there's a mux in front of this. So shift IR is 1, TDI value will be shifted inside. Shift IR is 0, DI value will be shifted inside. As simple as that. Okay. So please pause the video, understand this slide, extremely important to understand this because you have to correlate everything, visualize and connect all the dots in the end and explain me. Okay. So pause the video if needed, rewind, write notes. Let's move ahead. How to load instruction. Yeah, this is a self exercise again. I'm not going to explain this. This is very simple finite state machine. If you are good in state machine, you could do that. That's why you give a lab one, right? So let's stop here. Okay, pause the video, understand this, then go to next slide. Okay, I hope you see that. Okay, there are two control signals which instruction decode generates. This instruction decoder here, instruction register, instruction decoder will generate two signals. What is a mode signal? There are n number of mode signals it generates. TDI, we already saw this in the previous slide. Now we are going to talk about the instruction decoder. What is instruction decoder in terms of microprocessor? I don't have to explain, you already know that, right? If you have questions, please discuss among yourself or ask me in the classroom. Okay, mode registers, there are n mode registers. The select DR register. Okay, okay, so please understand this. There are two control signal generates. That's what is the concept. Uh, we will understand the rest of the logic in the coming slides. Okay, these are the mandatory data instructions. We would understand EX test instruction is mandatory, M for mandatory, O for optional. Three instructions are mandatory, rest are optional. So we will not go into this course. You have to read on your own if there is interest. If you want to develop a career in DFT, I would suggest you understand everything. But for this course, understand three instructions: EX test, bypass, sample slash preload. Okay. Rest are up to the designer, which is you, to decide you need the instruction him or not. Okay, so this again is up to you. This is a homework. I'm going to pause the video. Please understand how this state patient works. Take notes, discuss among yourself, and ask me a question in the class if you have any questions. Pause the video. Okay, hope you understood that. What is the purpose of EX test? Always ask this question. Any concept you study, why the hell I'm reading this? Sorry to use the word hell. Well, students like this a hell, I know, right? All the faculty gives all the assignments, they make your life terrible. So that's why I use the word hell. I apologize if it hurts you. EX test. Why the hell the EX test is there? It's called external test. It tests the external off-chip wire interconnection among the chips. Go to the previous video. There are three purposes we said, right? This is one of the purpose. So that's why we have this instruction. Look at this diagram. We had the same diagram before. Go back to the previous video. You would understand why the EX test is needed now. Okay, that's a JTAG instruction. It tests the wire among the interconnects of the chip to chip in the system. Okay, so how does it do? So this one chip, this another chip. This output boundaries cancel. We have seen that the part of the video in the beginning. These output boundaries, the input boundaries cancel. So data is coming from the output to the one chip. This is a wire under test. This is going to output input of the second chip. Right? You're testing two chips interconnect. Output of one chip to interconnect go to second chip. So you already you are applying the concepts. You learned what is the scan, update, capture, and scan out. The previous slides out of this video. Right now you have to apply that concept and connect the dots and tell me how it works. Pause the video, understand. Okay, boundary scan and the tap controller. Again, you have to do on your own homework. Simple logic. You understand, visualize, understand, take notes. Any questions, please ask. Again, this is a continue the same state. You have to understand this. Okay, pause the video and understand the slide. Okay, we'll stop here. It will become a little bit more complicated. Slide number 36, we'll do the next class. So wish you all the best. Understand all the concepts, apply the concepts, and enjoy the design for test. Enjoy it, feel it. That's how you enjoy. Otherwise, it'll be boring like mathematics. By the way, if you don't know mathematics, don't study engineering. Okay? But we'll avoid mathematics. But we'll do mathematics when needed as self-study. Right? Mathematics is very important in engineering. Okay, guys, I'll not bore you. I'll let you go. Bye bye.